Hey guys, Brian here. Welcome back to the shop. Got another somewhat challenging job here today. If you look at this manifold in the picture, from what you can see of it, it looks like it'd be pretty simple. It's just facing off a manifold, and if it was that simple, it probably wouldn't be here. So let's take a look at what I got going on. Yeah, that right there. That's the reason why this manifold's here. Most places have a belt sander or something they can throw a manifold on real quick, dress the face off and be done. But with that gooseneck sticking off the end of it there and the way of the flange, it kind of makes that difficult to do. You wouldn't be able to get to the end of the platen on most belt sanders. If it was a real small diameter roller, you might could get up that far, but it's still kind of questionable. Then it wouldn't be wide enough to do the whole face, and it'd be hard to keep it flat. So, and flat's what we're going after here, because this thing's warped and blowing gaskets. So it's a John Deere 8000 series manifold where they mount the turbocharger behind the engine. So that's why it's got this goofy manifold, looks like that. So that's what I got to work with, which makes a fairly challenging setup. Which I thought, well, I bolted to some angle plates, but can't really do that because you got to mill where the bolts go. So there's no way to really attach it there in that reference. There's one hole here, and there's one hole over there where some accessories bolt onto it, neither of which are in a plane, and neither of which are machined. On this side, none of these surfaces are machined to even go by for setting the bolt heights. So whenever they do this, it appears to me that they must have some sort of a clamp deal. They can come around and grab this manifold, and then they just mill it and put these holes in all from this side in one shot, and they don't have to worry about any of the rest of it. Same thing with these holes. I'm sure they're just drilling and tapping them through. Since they're not machined on either side, I'd say they're doing them from this side going that way. I do think maybe they do this flipped over upside down from the way I got it, because I'm gonna say these two lugs on here are some kind of a casting to sit on something fixture for alignment, but I don't really have any way to know what that height was. I guess I could guess, but all these bolt holes are in line, so I decided to go that route. The ones on the bottom side are not. This one's lower than these are, so can't set it on this way. That was initially the way I tried to do it. Then these flanges are not supported, but if I turn it over, I can get them all supported. Let's see, I got them sitting down on the blocks, and I've taken my screw jacks in the back to twist this thing up to get the flange straight. And I have to reach over the manifold so there's no clamps sticking across this side. I could probably come in here with some bar clamps and clamp it right across here. Maybe it would be better than going over the back like this, but I have these long clamps and can do it, so unless it tries to get squirrely on me, I'm not going to worry about it. Not trying to mill the world off, just a couple thousandths to make this flat. So there's the other side. You can see all the jacks involved with clamping this oddly shaped casting down to the table. So it worked, got it done. Thanks to Pierre and Phil. Be sure to check out their channels and tell Pierre to start making videos again, so y'all have something to watch. Those are good guys. Check them out. Pierre's Garage and Phil's Projects. They made these two jacks for me, and I've used them on a lot of jobs. They sure are handy. I'm sure everybody will complain about my garbage precision square I'm using here. It's just carpenter square for squaring this up, but you know, honestly, it's good enough for getting this stuff set up. So I can sit it down there and get it flat. Come up there. I can see it looks like it's maybe tipped over just a little bit. pretty good right there. Same right there. So, next thing I'm gonna do is fire the mill up and come in here and see how close I got. I also used my square for that in order to square it with the table. I just loosened it up, slid the blade in till it hit the flange. It's hard to do one-handed. Tighten it up, and then just go down through here and be sure that they're all the same. It's pretty close, so good enough to start indicating. I'm gonna get the mill fired up and see where we're at. Well, there it is. All resurfaced. Looks good. Got a nice finish on it. Nice and smooth. He's using MLS gasket, a multi-layer steel, so you want a smooth finish on it. You don't want a rough finish, not on a steel gasket. You want smooth. So, and that's smooth. challenging work holding and coming in on that angle to make that cut, clear that gooseneck, but turned out good. Well, I hope you enjoyed getting to see this little job knocked out on the boring mill. It'd be tough to do this on any other machine, just because of the challenging work holding involved. Seems like to me, I don't know, maybe some people could do this on a surface grinder. I guess if it was big enough, you could come in and leave that one end off out past the wheel. Still be challenging to hold this thing up on its back to surface grind these flanges. So I guess it's the ideal way to do this, and that's why I got the machine to do it with. Thanks for watching, thanks for subscribing, I'll catch y'all later.